In this video, we're going to look at topic 83, example 2, identify even and odd functions from their equations. The question is the function even, odd, or neither? So what we need to test for is, we need to remember that for it to be even, f of x is equal to f of negative x. So if I were to change x to a negative x, I should get the same function. If it is odd, then f of negative x is equal to negative f of x. Okay, and we'll see these in play when we do examples A and B. So to figure out whether a function is even, odd, or neither, if you're not given the graph, what you want to do is you're going to take the function and you're going to replace all of your x values with a negative x. Okay, so I'm going to replace this x. Well, that's not what we wanted to do. I'm going to replace this x with a negative x. All right, if I were to look to simplify this, what I need to do is I need to figure out the signs of each term. Well, the plus 5 is a constant, so that's not going to change. What I want to look at is if I have negative x to the fourth power, think of this as, let's say, negative 1 to the fourth power. All right, negative 1 to the fourth power is multiplying negative 1 4 times. Now, you wouldn't have to show all this work. You'll get the hang of this, but I want to explain it. This would become a positive 1. This would become a positive 1, which means if I multiply them, I get a positive. If you have an even power, a negative times itself an even amount of times is going to give us a positive number. So what happens is this 4 to the negative 4x to the fourth is the same as 4x to the fourth power. Now, if we go to our rule over here, for even functions, f of x has to be equal to f of negative x. Well, if I look at this line here, the first original line, f of x, and I look at this line here, these two are the same. Right? Since they're exactly the same, that tells me that this is an even function. Right? And it is even because f of x is equal to f of negative x. Okay, that's my reasoning or my justification, or if you want to think of it as a proof. Okay, but this is an even function because everything is exactly the same. Let's do the same thing with g of x. So I'm going to take g of x and I'm going to make x negative. So I have 2 times negative x to the third power plus 3 times negative x. And I want to do the same thing here. I want to see if my signs change for each term. So g of negative x would be equal to, well, negative x cubed, right? Let's just pretend we use a negative 1. If I multiply a negative 1 3 times, sorry about that, this would become a positive 1. That negative 1 comes down, and then I would get a negative as my result. So anytime I'm multiplying a negative an odd number of times, it's going to be negative. So this negative x cubed times the 2 is going to cause that term to become a negative 2x cubed. It might take a little practice to get used to that, but just remember, if you're not really sure what to do, just plug in a negative 1. All right, and if I were to multiply this out, I'd get a negative 2. Keep the x's obviously when you're doing the problem, but use this piece here as a little test to figure out whether the result is positive or negative. Positive 3 times negative x, that's pretty obvious, that's negative 3x. Okay, now in this case, we're looking for whether it's even or odd, and we want to compare this one here with this one here. Now, the 2x cubed became a negative 2x cubed. All right, so that sign changed. It's an opposite sign. So it can be even, because we have some changes here. The 3x became a negative 3x. Right, so what happens is all signs changed. 2x cubed, positive 2x cubed became negative 2x cubed. Positive 3x became negative 3x. So since all signs changed, that tells me that this is an odd function. And the justification is that f of negative x is equal to negative f of x. Again, that's the reasoning, the proof, the justification, however you want to phrase that. What you want to keep in mind, for it to be even, all signs remain the same. For it to be odd, all signs change. Okay, odd has to be every single sign has to change, not just some of them, not just one of them. Every term has to have its signs change for it to be an odd function. And for it to be even, everything must remain the same. If anything changes at all, it is not even. If anything stays the same, it is not odd. If there's a combination of it staying the same and it changing, then it'd be classified as neither. Okay, it would not be odd and it would not be even. You'll see that in one of the tried examples. One of those is potentially neither. So just be careful. The whole issue that students usually run into here is taking these negative x values and just kind of forgetting whether they should be positive or negative. So just be careful with your exponents. Remember that if it's an even exponent, like in part A, that 4 is an even exponent, so the negative x will turn out to be positive. In part B, we had odd exponents, so those signs would remain as negatives.